What's up, everybody? I want to do some videos here and kind of go through some of these Ethernaut challenges. If you're not familiar with Ethernaut, this is I guess, a subdivision or a challenge put forth by OpenZepplin from here. It's very similar to like a capture the flag or like a leak code challenge, if you're familiar with those. But in this case, since we're doing smart contracts and the very nature of smart contracts are a little bit different, all these challenges here are based around smart contracts. So it's kind of like leak code, it's kind of like capture the flag, but it's its own thing. I have a lot of fun with them. I did a few of them on my own time from here, but we're gonna do at least do one today here, and we're gonna make some videos, and we're gonna have some fun here. We can see there's different challenges. Some of them are harder, some of them are easier. Let's do the first one here today. So the first one is Hello Ethernaut. Let's go ahead and click on that. Now for this, you will need some test Gorelli in your Ether wallet. Depending on, I think this only supports Gorelli at the moment. It might support other subnetworks or other test networks. I shouldn't say subnetworks. It should support other test networks, but right now I'm using Gorelli. I know that Gorelli works. And so yeah, if you don't have any Gorelli, I'll leave a link in the description. I believe it's just GorelliFaucet.com. You do need an Alchemy wallet, or an Alchemy account, I should say, to get some of that test ether. This way people aren't spamming it, so that's kind of how they keep track of that there. But you can see we have some steps from here. And the first one's pretty self-explanatory here. We're going to kind of go through each step here. So first one here, set up MetaMask. If you don't already have it already, install the MetaMask browser extension, blah, blah, blah. If you don't know what MetaMask is, you probably don't have any business doing this stuff right now. Anybody that's ever worked with blockchain or smart contracts before, you probably know what MetaMask is. Even if you don't like it for some reason, you probably at least know what MetaMask is. So for this particular application, for this particular website from here, it requires that we use MetaMask. All right, so we already have that. I have installed. Hopefully you guys have installed too. Seems pretty simple here. Step 2, I'm going to open the browser's console. Depending on what browser you're using, I'm using Chrome here, so we're going to go ahead and open that browser from here. Now you can see we have access to some different things here. We have access to some different commands that work with this website, with this web app, that normally wouldn't work. Like if I type in player, we can see that we get my wallet address back, which is the same on my MetaMask. If it will load. Come on. There we go. So same address from there to there, right? I can also do something like get balance, player. Now if I enter, player is not defined, always helps to spell things correctly here. This won't work in Chrome. I believe some other browsers it might work here. Basically because it's an asynchronous function, we need to add a wait. So get balance, player. And again, always helps spell things right here. And then we should see the same balance, same test balance that's in our account from here. And you notice I'm connected to the Gorelli network from there. So this is all matching up and this is all working properly from there. So it looks like we did step 1, step 2. Again, let me know if I'm going too fast or too slow for you guys here. Sometimes I feel like I'm jumping around. Other times I feel like I'm over-explaining. So just let me know here. If there's anything I kind of gloss over, be sure to let me know down below here. But we have MetaMask here. We open the browser console here, and we're able to run some of these commands that interact with this web app from here. So step 1, 2, and 3 are done here. Let's move on to step 4. Enter the following command in the console, Ethernaut. Now if I enter from here, we can see we have access to this variable, which has a bunch of different information from here. We have a contract address, and we have some different things going on from here. Of course, we could poke around this a little further, which we will in a second. But anyways, let's go ahead, let's read a little further. This is the game's main smart contract. You don't need to interact with it directly through the console, as the app will do it for you, but you can do it if you want to. Playing around with this object now is a great way to learn how to interact with other smart contracts of the game. Go ahead and expand the Ethernet object to see what's like inside. And again, we kind of already did that from there. One of the things that you should kind of take notice of is this ABI from here. If I expand this down here, we can see that we have access to different methods, different public methods that are within the smart contracts from here, right? And these are going to come in handy in a little bit here. So now step 5. Ethernaut is a truffle contract object that wraps up the Ether.sol contract and has been deployed to the blockchain. Among other things, the smart contract ABI exposes all the Ethernaut.sol's public methods, such as the owner. Type in the following command, for example. So again, we kind of already did that. I'm kind of one step ahead throughout this entire video here. I expanded the ABI. This is what they're talking about right here. Do note, sometimes I know that it's kind of hard to, when you're listening to somebody, it's not API. This is ABI, right? So let's do exactly what it tells us to do. Ethernaut.owner. Ethernaut.owner. And again, let's do an await there. I'm not even sure if I need, yeah, okay, we're good. So now we can see who's the owner of this contract from here. This method is the same as this method from there, right? It outputs one thing there. It's a view function because we're not modifying the state of the blockchain. We're just viewing some information on there, and this is what comes back, all right? Or await Ethernaut.owner if you're using Chrome version 62. Again, that's kind of what I did right there. Get test ether. To play the game, you need test ether. The easiest way to get some test ether is to send is via a valid false of your chosen network. Again, so it sounds like it supports other networks. I'm using Relay right now. I mentioned that earlier that you're probably going to need some, or you will need some, to interact with these contracts from here. Anyway, step 7, getting a level instance here. So essentially what we're going to do here, let's read through it because I'm always one step ahead. When playing a level, you don't need to interact directly with the Ethernaut contract. Instead, you can ask it to generate a level instance for you. So instead of interacting with this particular contract, we can have our own contract to interact with that we can kind of work with, which is cool because once we start to do this further here, there's different ways that you could kind of mess up the contract. You could kind of mess up. It's nice to have like your own instance of the contract, and this way you could always reset it if you wanted to. Cool. And so you ask the level instance for you. To do so, click the Get New Instance button at the bottom of the page. Go do it now and come back. So let's do that. Get New Instance. Then you're going to see this pops up from here. We need to approve the request through MetaMask. Confirm. Now again, I would highly suggest using a test network. If you're on the main network, that your request might still go through, but it's going to cost you obviously real ether, If you are made of money, then I guess, you could do that if you wanted to, but I'm going to do the test network. So it looks like we have the transaction. We can click on this from here if you want to see some of the details. Looks like it went through. Cool. And let's go back to Ethernaut. And now we have an address instance from here. Now, if you're ever doing any sort of capture the flag or hack the boxes from here, it's nice to have a little scratch pad to kind of work with. So, of course, I have a bunch of monitors from here. Not of course, but you can kind of tell that I have a bunch of monitors by the way that my mouse is moving. So what I'm going to do is I'm going to go to, let's just do a Google Docs real quick. Come on now. Which I probably should have opened before the video started, Google Docs. But that's okay. There we go. So that's looking correct from there. Looks like I pasted it properly. Now we can, blah, blah, blah. You should be prompted by MetaMask to authorize a transaction. Do so. You should see some messages in the console. Note that this is displaying a new contract in the blockchain. It might take a few seconds. So please be patient when requesting the new level instances. Again, we kind of did that already. Now, inspecting the contract. Just like you did with the Ethernaut contract, you can inspect this contract's ABI through the console using the contract variable. So let's say contract, and let's see what happens now. So we know this is our contract because the address is the same as the instance address from above here. So we're talking about the same thing from here. If I expand this down here, we have 11 functions that we can call, which is very similar to above here. This one has 13 here. This one has 11. So I guess not very similar, but similar in nature. If I expand this down here, we have some different names of functions and methods from here that we can start to work with. So if if you've never done any sort of stuff like this before here, once you see this information, your ears should start to like perk up and your eyes should start to open up from here, because this now allows us to start poking around with more information and get a little further along basically towards our goal. All right. Inspecting the contract, you already did that. Interact with the contract to complete the level. Look at the levels method, contract.info, or await contract.info if you're using Chrome GE2. You should have all you need to complete the level within the contract. When you know you have completed the level, submit the contract using the submit button at the bottom of the page. This sends your instance back to Ethernaut, which will determine if you have completed or not here. Cool. So it really doesn't tell us what exactly we need to do here, but we do have some information. Contract.info. Let's try contract.info. Await contract.info. And again, this is the same as that one right there. Contract.info. Enter. You will find all that you need in info.1. So now we're going to run that function, info.1 here. Try info.2, but hello is a parameter. And let's try hello. So again, this contract itself isn't too hard here. We have info2, and we're taking in, see if I can expand that down there. It's info1, info2. We are taking it in. It should say we're taking an argument here. Ah, there we go. So we're taking an argument. I believe that's correct there. Let's run it. Let's see what happens there. The property info num holds the number of the next info method to call. So if you look at here, we can probably deduce it's either probably info 42 because that's the only one that's there. But if this contract was a little more complex, this might be a little harder to do. But anyways, from here, let's go ahead and stay in order. We're going to say await contract.info info num. And what do we do wrong there? Array.2 contract.info num. Words 42. So we're getting back 42 there. So again, we can probably deduce that it's info 42 is the next method we have to call. And let's see what happens now. The method name is the name of the next method. The method name. Let's see if we have that. The method name. We don't have any input. So again, I'm going to say the method name. The method name is method 71 23 94 9. This method from there. Whoops. Copy that. And it should even kind of do like an autocomplete thing. The method name. Oops, not the method name here. Method 71, whatever. Run that. If you know the password, submit it to authenticate. Now we don't know the password here, but if we go back to these functions, we see this password function from here. So let's run that here. So let's go ahead and copy this here because this is a good note to have. I'm going to copy that. I'm going to paste this for my notes here. We're going to say this. We'll say something like result of the, what was it, method 71, whatever. Just copy that from there. And now we want to call, if we take it back a step or two, we want to call that password contract, that password, with no arguments from there. And the password looks like it's Ethernaut.0. So let's go ahead and copy that. We're going to submit it to authenticate. So we're going to say await, await contract dot authenticate. That might have to be double quotes there. And we're going to approve this transaction through MetaMask. Confirm. Send transaction. Let's wait to see if the transaction is confirmed. The only method here, as I'm waiting, I'm kind of looking back here, the only method we didn't call is get cleared. Get cleared. Interesting. Okay, no problem, but we can always come back to this here. We have the transaction confirmed. We have the transaction receipt here. And it seems like we did everything right here. Now, it doesn't give us any information back, like good job, but you got it. So I believe since we had to send some Ethereum or test Ethereum to this, we changed the state of the contract somehow. This isn't a view function anymore. So because we changed this, because we submitted that password to this seems like it would be correct. I really don't see any reason why this would be wrong. So let's go back to the actual website here and let's say submit instance. And let's see if we did this properly. Confirm. And it looks like we completed this level. We get some cool, I guess you'd call this ASCII art. Looks like ASCII art to me. Those look like that looks like a Japanese symbol. I don't know what that pumpkin is there. I mean, it's supposed to be a face or something. I don't really know. But it looks really cool, and it looks like we did it properly here. And now we have the contract here, which we can kind of take a look at. We have the password being set up there, the password there. So it's funny, even if we could have the password, or even if we had access to the contract beforehand, the password looks like it's submitted at runtime. So when the constructor function is called, it's given the password. So even if we could look at this contract, we still wouldn't know the password until we ran these functions from there. Function authenticate, that takes in. So that get cleared method is really the only method that I'm curious of what it does. Public review returns cleared. Interesting. I'm not entirely sure what that does, but cleared equals false. Return cleared. Interesting. There's a bool there. I'm not exactly sure what that does. Hey guys, it's me from the future. I just realized that as I was editing this video here, This cleared function basically has to do with if you beat the level or not, if you cleared the level or not here. Because once we ran this authenticate password from here, it's basically taking in the passkey here and it's seeing if it matches up with the password from above. If that is correct here, it sets the bool equal to true instead of false here. So essentially when their system per se runs and checks to see if we cleared it, if we beat the level, it's kind of writing this function from here. It's saying, hey, did you beat that level? Because by default it's false here, and it's only set to true if our submission is correct from there. But anyways, it looks like we did this properly here. So if you guys enjoyed this video, be sure to give me a comment. Thumbs up, comment, and subscribe. If you guys did enjoy this, if you guys think I'm rambling, I'm all over the place, be sure to let me know. And like I said, I'm going to do some more videos of the Ethernaut challenges because I think they're a lot of fun. And I will talk to you guys soon. Have a great day.